Now we wish to put everything together and show the code for the graphic shapes class. This class contains the main method, and we'll walk through that to see how we construct these objects and make them draw on the screen. So here we have class graphic shapes, and I have comments here that show the general approach we have to use to draw on a frame. First, we're going to have to use inheritance. We have to extend a class from the Java library named JFrame. It's one of the swing components. So if you see or hear referenced the swing classes, those are the graphics user interface classes from the library that we will use to draw our shapes. So our graphic shapes class will be a JFrame. In order to extend JFrame, that'll give us a component on which we can draw. It's called the content pane. Every JFrame has a content pane. We'll then have to create an instance of the JFrame class and then override the paint method, because all JFrame objects respond to a paint method. When the environment determines it's time to draw that frame, it calls its paint method and passes it a graphics object. So this is otherwise known as event-oriented programming. So our program main is not in control of the drawing. The Java environment is, and it determines when our JFrame needs to be drawn, and when it does that, it gives us a callback. It'll call our paint method and passes the graphics context in which the redrawing needs to happen. That's how the paint method works. So graphic shapes is going to override a method called paint, which is the last method here in the class, and it's really going to be quite a simple method. We're going to call the parent class JFrame to paint the background. And then what we're going to do then, once that's finished, is loop through our graphics shapes list, our GSL list. This is a for each iteration loop in Java. And now we want to investigate how GSL works. The graphic shapes list is defined right here on line 208. It's an array list of drawable objects. That's the nice part about an interface. If we had made this an array list of points, we could only draw points. If we made it an array list of lines, we could only draw lines. But because all of our graphics shapes implement a drawable interface, and because drawable is a kind of data type, we can simply say that our graphic shapes list contains drawable objects, which can be all of these classes. So that's how you use interfaces to make your code more generic. So by having an array list of drawable objects, any object that implements the drawable interface can be stored in this list. So that is the declaration and creation of GSL, our graphics shapes list. Now in main, that's where the flow of control begins. We have one simple line of code here that kicks off the whole execution. Our graphic shapes is a kind of JFrame. So when we call the constructor below, that starts here on line 219, we're going to create an object of ourself and simply call it drawFrame. That alone will kick off all the events that we need to draw the shapes on JFrame, as is shown here. So let's investigate how the constructor works. When we create a new graphic shapes object, we run the constructor here, and the constructor is invoked on the right-hand side of this assignment statement. So the constructor sets the title bar in our parent JFrame, and then it calls another helper method named setupShapes. SetupShapes is right below us right here. Now once SetupShapes is done, these are other messages that a JFrame object understands. It understands already how to set the size, and that's 400 pixels wide by 250 high. We set it visible, and then we set the default close operation. So when we close the window, it actually exits our program. And so these are just things you can do with any JFrame object, and when we make a call to them, since our graphic shapes class does not define them, it goes back to its parents class to see if it's a definition there. And there is. That's one of the nice things as well about inheritance. If an object receives a message and it doesn't implement that behavior, it'll turn to its parent class to say, does the parent know how to implement the behavior? And if it does so, fine, it executes it. If not, it'll go to its grandparent or its great-grandparent, all the way back up the inheritance hierarchy, all the way back to the root object. In Java, the root object of all classes is a class called object with capital O. It's in the Java docs. You can read about it, but all classes from Java extend that basic class object. And so the Java hierarchy is really a one large tree, and we can extend that tree using inheritance. So let's take a look at how we run our setup shapes method. Well, we have to create some points. We create an origin and point 2, and a line, and then a fancy line. Here, notice the data type of the object, another one, is of type line and not fancy line. That's referred to as upcasting. So we can have a more specific object referred to by one of its ancestors in the inheritance hierarchy. It's still a fancy line, however, so the object called another one will understand any messages that fancy line objects can handle. So we create a couple of fancy lines here, and then a unit circle and a can for a cylinder. Now those just created the objects. We now have to add them to our graphic shapes list. And so an array list has an add method, and so those objects, origin, point 2, the 2 lines, two fancy lines, the unit circle and the can cylinder, are all added to this list that was created up here on line 208. So we create the objects, add them to the list, and just for debugging purposes, I then go through the list and print out each object one at a time. Remember, each one of these classes implements a toString method. So when I do a system.out.print line on an object out of this list, and this is how we get objects out of a list, I have an ordinary loop variable here, I, and I tell the graphic shapes list, get element 0, then get element 1, then get element 2 through successive iterations of this for loop. As those objects are fetched out of the graphic shapes list, sending them to system.out.print line simply invokes their toString method, which will result in these lines being printed right here, down here in the console. And that's it for the setup. That's the setup shapes method, and it notice it ends here at line 250. Now the only other behavior is this paint behavior, and the paint behavior is what's being invoked when we run the program. Go ahead and run it here. We get the new console output down here, and we get the drawing on the JFrame here in the center of the screen. What happens when we create a new JFrame is the system decides when it's time to paint that window. And so we get a callback here. This paint method is not something we call. The system calls us when it determines it's time for us to paint our JFrame. So this is a callback to us, and what we do is send the paint method to our parent class. Remember, we're in class called graphic shapes. We're in this class graphic shapes, and our parent is class JFrame. And so there's some basic behavior for drawing a J-frame that we don't want to miss. We don't want to take over all of these events. We'd like our parent class to implement the normal paint method that it normally does. So again, we're piggybacking on behavior we've inherited from our parent class J-frame. So that sets up the background. It gives us the borders, things like that. When you have a J-frame object, you've noticed from Windows in Experience, you can hover over the edges and stretch the edges out. And while I'm doing this, by the way, paint is being called many, many times to keep repainting this canvas, this J-frame content, so we can continually see the output. That was many, many hundreds, maybe thousands of calls to the paint method to keep this display refreshed. That's all part of the Java event loop for graphical drawing. Now, when we hit our method, we first call the paint method on our parent to be able to have those borders. That's why it's called a J-frame, because the frame is movable and stretchable. And then we have a for each loop here that just goes through our graphic shapes list and pulls out a drawable object S, and notice S is of type drawable. So that's any class that implements the drawable interface. It may be pulling out a circle or a point or a line or a fancy line. It doesn't matter. It's just an object S that we know is drawable. Since all drawable elements must implement a draw method, that's what we do in the body of the loop. We take that object S and send it the draw method, passing it the graphics context object G so that it can draw itself on that graphics context. That's the content pane of the J-frame. And so putting it all together, we get this nice drawing behavior, which is set up programmatically pretty well. It's pretty logically implemented so that we can easily extend and do more with line-oriented drawing.